So in the last video, we ended with the sixth enzyme in glycolysis, which is glyceraldehyde 3-phosphate dehydrogenase. Now that enzyme ended up catalyzing two key things. There was a phosphorylation that occurred with the inorganic phosphate, and there was a redox reaction. And remember, when the two hydrogens are removed and put onto NAD, NAD becomes NADH. So NAD is the oxidized version. NADH is when the NAD gets reduced, it becomes NADH. We have to count all these NADHs, these reduced versions of NAD, because we're going to see them later on in the electron transport chain. So far we haven't produced any ATP. Up through the sixth enzyme in glycolysis, no ATP has been produced. 2 ATPs have been put into the system in the first enzyme and the second enzyme, those 2 kinase enzymes. Now, right now, we have 2 1,3-bisphosphoglycerate. So I have 2 of them. Why do I have 2 of them? Remember how we went from the 6-carbon fructose 1,6 bisphosphate to the glyceraldehyde 3-phosphate and the DHAP, and then the DHAP got turned into glyceraldehyde 3-phosphate. So we had 2 glyceraldehyde 3-phosphates, and then those 2 became 2 1,3-bisphosphoglycerates. Okay, so this is what 1,3-bisphosphoglycerate looks like. This over here, this is a high energy bond, this carbonyl and this phosphate group with this double bond. So because this is high energy, when we break this bond, and we can put it onto an ADP and turn it into ATP. So the next reaction deals with transferring a phosphate group. And anytime you transfer a phosphate group and ATP is involved, it's a kinase. So this enzyme here, this is the 7th enzyme, is going to be phosphoglycerokinase. Okay, so that's the name of the 7th enzyme. So we've got the 1,3-bisphosphoglycerate plus ADP. Everything is 2, so you have 2 of these, 2 of these. We'll turn it. Now this right here is going to go on to ADP. And if it goes on to ADP, adenosine diphosphate, and you add in an extra phosphate, then it becomes adenosine triphosphate. So you have ATP. So this is the first time in glycolysis that we're actually making some ATP, that we have ATP as a product. So we're going to have ATP. And then once this goes away, you have this molecule. So ADP becomes ATP. And you have this molecule. Now this molecule here is 3-phosphoglycerate. Notice all these phosphate groups being moved around. All right, so now we've got 2 ATPs. We have 2 of these, and we have 2 of these. So think about this. Net so far in glycolysis, we put 2 ATPs in, we got 2 ATPs out, so net we're at 0. So far we have no ATPs. And remember I told you, when everything is said and done, when we're done with all of the steps of metabolism, aerobic metabolism, you're going to eventually get 30. Right now we're at 0. Okay? So we've got 2 3-phosphoglycerates. This reaction here that we just did, this is a phosphorylation. And we said we call this substrate level phosphorylation. What does that mean? It means that you removed a phosphate from a substrate to put it onto ADP to make ATP. So this type of phosphorylation is substrate level phosphorylation, which is different than the oxidative phosphorylation you're going to see in the electron transport chain in the mitochondria. So here we just had plain old phosphate level phosphorylation with this kinase enzyme. All right, so what's going to happen next? The next enzyme is catalyzes an isomerization reaction. Remember in a previous video, I told you that a mutase enzyme is a type of an isomerase. So the next enzyme is phosphoglyceromutase. This is an isomerization reaction, meaning I'm going to create an isomer of 3-phosphoglycerate. What I do in this reaction, in this isomerization reaction, is I just take the phosphate group and instead of it being on carbon 3, I bring it up to carbon 2. Okay, so I'm going to turn the 3-phosphoglycerate and I'm going to turn it into 2-phosphoglycerate. Okay, and I'll just draw it out here for you guys. Now it's 2-phosphoglycerate. So all I did was I took this here, flipped it around. All right. This is an isomer of 3-phosphoglycerate. How many 2-phosphoglycerates do I have? I have 2 of them, right? Because everything started to become 2 after the DHAP got turned into glyceraldehyde 3-phosphate. All right, so phosphoglyceromutase was the 8th enzyme, and it catalyzed an isomerization reaction. All right, now the next reaction is a dehydration. So it's not a dehydratase enzyme. It's called something else, but it is a dehydration reaction, meaning we are going to be removing a molecule of water from 2-phosphoglycerate. Do you guys remember when you dehydrate an alcohol, you can turn it into an alkene? Hopefully you remember that from your organic chemistry that we did. If I take OH, can you see that you remove a molecule of water and you end up creating a double bond between these two? So this next enzyme catalyzes this dehydration reaction. This is enzyme number 9. And the name of the enzyme, the way I remember it, is that since it dehydrates and creates an alkene, the enzyme is enolase. So that term "ene" will sort of remind you of that. So this is enolase. Enolase is enzyme 9, and we're going to remove a molecule of water, HOH. Okay, and we're going to create, a double bond right here. Okay, there we go. So now this is not 2-phosphoglycerate anymore. We have 2 of them. Plus and 2 waters. But what is this product called? This product has an acronym PEP, or phosphoenol pyruvate. Okay, so enzyme 9 takes 2-phosphoglycerate, dehydrates it, removes an HOH, produces water, and you end up with PEP as the organic product. PEP stands for phosphoenol pyruvate. We're almost done with glycolysis. See, remember how I told you that glucose is going to get turned into 2 pyruvates, so you're beginning to see the word pyruvate show up. All right, the last reaction takes this phosphate group and puts it onto ADP to produce ATP, another substrate level phosphorylation. And since we're going to be transferring a phosphate, and since ATP is involved, it's going to be a kinase. All right, so your last enzyme of glycolysis is named pyruvate kinase. And we're going to take PEP, okay, plus ADP, because you got to put the phosphate onto something. This phosphate group is going to go on to ADP, and what will it turn? It'll turn into ATP. And then what's left over? Well, there's a bit of a rearrangement that goes on. Let me tell you what the product out. So you've got PEP plus ADP will give you ATP plus pyruvate. This over here, you don't need to worry about the structures, but like I said, I like to see what is going on a molecular level. I personally like to see the structures. So this is pyruvate plus ATP. And remember, everything's double, so you have 2 pyruvates, 2 ATPs. So let's think about this. Remember, you put 2 ATPs in, you already got 2 ATPs in a previous enzymatic reaction. And then the last enzymatic reaction of glycolysis, you got 2 more ATPs. So net out of glycolysis, what are we getting? We're getting 2 ATPs net. So by the end of the 10 enzymes, you have an output of 2 ATPs. And you have an output of 2 NADHs. Remember, I told you these guys, we're going to be seeing them in the electron transport chain. That's why we have to pay attention to them. And then obviously you have 2 pyruvates. Okay, so when we go into the next video, we're going to talk about the fate of pyruvate. What happens to pyruvate? Well, a lot of it depends on if the cell is in aerobic conditions or anaerobic conditions. And what type of cell is it? Is it a human muscle cell? Is it a bacterial cell? Is it a plant cell? What's going on with the pyruvate? Okay, so we'll do that in the next video.